What if Nazi Germany did invent the ultimate weapon? What if some clever scientist successfully built a missile that could carry tons of high explosives to any place, any city in the world? A weapon that fell from the sky without warning and at such high velocity that no one could hope to stop or intercept it? Scary scenario. But perhaps even more scary is the fact that they actually got kind of close to doing this. I'm Indy Neidell. This is a World War II in real-time special about the V-2 rockets. Okay, in the late 20s and early 30s, there was a real craze for science fiction in books and cinema for the secrets of the universe. You had rocket-propelled cars, sleds, and planes breaking speed records and creating what in Germany was called the rocket rumble. And for a bunch of engineers, scientists, and students of the small German Society for Rocketry and Space, the realization of interplanetary travel seemed only one major breakthrough away. According to famed Professor Hermann Oberth's theories, the future lay with large missiles powered by a liquid mix of oxygen and gasoline that reached beyond the Earth's atmosphere. Problem was, building such a missile not only needed the necessary brain power and enthusiasm, but lots and lots of money and resources. Then, in a time of mass unemployment, a tempting offer came from the German military. The Wehrmacht's Weapon Research Department would provide everything they needed, from access to rare resources and fuel, to the means of organization and administration, to a place where they could build and measure their prototypes. In exchange, they got ownership of everything, all patents, inventions, and intellectual property. Some scientists balked at this, but most of the brightest minds, like Walter Riedel, Walter Thiel, Walter Dornberger, agreed to join up. Beginning in the summer of 1932, on the artillery range at Kummersdorf, the German Rocketeers were set to follow the lead of Wernher von Braun, 20-year-old prodigy in physics and astronomy. Although there were many prototypes with various specifications, the main goal would remain the same: building a light metal rocket able to cover a distance of at least 250 kilometers while being no heavier than 12 tons nor longer than 14 meters. It was to be a liquid propellant, unmanned, self-guided missile that traveled at supersonic speed at the edge of the Earth's atmosphere. But while the scientists wanted to go to the moon, the military sought the ultimate artillery shell. The first of these rockets were rather modest, yet promising. Aggregat 1, Aggregate 1, was just 1.4 meters long, weighed 150 kilos, and gave a thrust of 300 kilos, but was somewhat unstable during flight trials. A2 was already a major improvement, solving the stabilization problem not with a rotation top, but a heavy centrifugal gyroscope inside. When shown to Adolf Hitler in October 1933, the Führer showed exactly zero interest in the whole idea, later even arguing that such a rocket would never take flight. Military men, however, were taking notes, and von Braun promised that they were just exploring the potential of such a missile weapon when it came to range and the size of impact. Working with cutting-edge technology and with visionary goals in mind, the rocket program often required parts that had to be invented specifically. Things like more powerful fuel pumps that could accelerate the pressurized gases quickly enough. Most of it was miles ahead of what was available on the market, so planning, building, and testing went hand in hand. Millions of Reichsmarks had to be put into acquiring people, resources, laboratories, precision tools, and above all, a new place to try it all out. They eventually found the perfect testing place on the Baltic island of Usedom, called Peenemünde. By November 1938, the rocket program had something to show. 50% of all new Aggregate 4s launched reached a range of 300 kilometers and then came down within a 7-kilometer range of the target. This got them the vital support of Albert Speer, who laid out plans to mass-produce the A4 as early as 1941, putting the rocket program on the same level of importance as the U-boats and the Ju-88. See, to distribute resources and skilled labor, the German war industry organized itself by levels of urgency. But the final word lay with the Führer himself. Every branch of the military needed precious steel, and Peenemünde required at least 6,000 tons a month to keep the 1941 plan going. Hitler only allowed them 2,000. Dornberger and von Braun repeatedly appealed to Nazi leadership, pointing out that while Germany was now far ahead in rocket science, the US and the USSR might catch up if they did not follow up on it. But Hitler wanted a weapon he could use now, not in 3 years. The quick victories over Poland and France put the rocket program even further down the list, only to be brought back on top again as the Luftwaffe failed to win the Battle of Britain. Then, however, the invasion of the Soviet Union prioritized tanks and other such equipment, so it was back down again. And yes, this back and forth made it impossible to keep a consistent production schedule going, and things really stagnated. There was also competition from within. Not only did the Luftwaffe constantly fight for resources for their planes, they also made a competitor to the A4, the Flugbombe Fi-103. This flying bomb was a pulse-jet-propelled air torpedo. Far cheaper to produce, at only 3,500 Reichsmarks each, compared to the A4's 144,000, it also needed less steel and consumed less fuel, of a lesser quality. The flying bomb, however, was much slower, produced a lot of noise, and was easy to spot on radar. The A4, though, did not need large installations to launch, and was, in principle, impossible to shoot down once it re-entered the atmosphere, and it would hit its target with an immense force. Left with the decision over precious resources, Nazi leadership chose to continue both projects, of course, pleasing absolutely no one. Work on the A4, which propaganda began to call the V-2 for Vergeltung, or payback, continued, albeit very slowly, with von Braun trying to iron out the issues still plaguing the imperfect rocket, like stabilization, pathfinding, and a homogeneous burn of the propellant. The flying bombs, by the way, got the name V-1. But V-2 work would soon enough be interrupted again. In autumn 1942, British intelligence was tipped off by a Danish chemist that the Germans were supposedly building a war-changing superweapon. After months of gathering evidence with aerial photographs of Peenemünde and reports from the Polish resistance, as well as interrogation records, the British became seriously worried. Unlike the Germans, the British had experimented only with solid powder rockets, not liquid fuel, and underestimated the possible size and power of such a missile. Well, in August 1943, they launched Operation Hydra, which saw nearly 600 heavy bombers hit Peenemünde. 738 people were killed, among them 178 scientists and more than 500 foreign workers. It was a major blow to the German rocket program. Although not fully destroyed, the deaths of so many important scientists delayed the prototype once again. However, in October, the remaining scientists around von Braun, Thiel, and Dornberger were finally ready to reveal Aggregate 4 as a ready weapon. With a length of just over 14 meters and a diameter of 1.65 meters, the rocket could carry 990 kilos of explosives inside its head. The steel at the top of the rocket was 6 millimeters thick to withstand a temperature of 680 degrees Celsius during the re-entry into the atmosphere. Because of this enormous heat, the V-2 could only carry regular explosives and not the much more volatile trialin. It was fueled by a mix of 75% ethanol, 25% water, with liquid oxygen as an oxidizer. This had to be kept at a temperature of minus 186 Celsius. The fuel and oxidizer pumps are driven by a steam turbine running on a mix of hydrogen peroxide and sodium permanganate. The hot gases of 385 degrees would bring the turbine to over 3,800 revolutions per minute. An initial thrust of 3 tons would ensure an even combustion and would then be raised to 25 tons in order to propel the rocket upwards. Azimuth and inclination gyroscopes control the graphite rocket steering paddle and stabilizers using electronic and hydraulic commands. The whole rocket was programmed to incline itself autonomously to the defined path. Once underway, it was impossible to influence the rocket's trajectory. As its fuel was cut off, it would automatically activate the fuse. After a rise of 90 kilometers, the rocket would then steer itself into its ballistic curve towards its target. The V-2 would reach a maximum speed of 1,500 meters per second after just 63 seconds. It was calculated that the impact of the rocket would lead to a crater 14 meters diameter and 7 meters deep. This impressed the Fuhrer, who even admitted that he had been wrong and should have prioritized the program from the start. Now the V-2 would only need to be mass-produced and the war might be turned around. Easier said than done, though. By now, Allied bombardment of production lines was bad enough that a V-2, a rocket made out of 2,000 individual parts, had serious problems getting together. Peenemünde had to be given up, and a system of tunnels underneath the Harz Mountains at Nordhausen was chosen instead. Here they set up Dora, a sub-camp to concentration camp Buchenwald, to house thousands of foreign resistance fighters and German communists and employ them as slave labor. Living conditions were hell, sabotage was high, and punishment severe. By the end of 1943, more than 11,000 inmates were forced to work in an immense program to supply Nazi Germany with thousands of rockets. By May 1944, Hitler had greenlit the bombardment of London, though with the V-1 flying bombs. As von Braun had feared, the V-1s were much too slow and too easy to shoot down to be a true game changer. By September, the V-2 was ready to fall onto the British capital. Although the numbers killed were painfully low in comparison to the destruction British bombers were wreaking on German cities, there was indeed no way to counter the V-2 at the time. The attack was sudden, silent, and with immense velocity and impact. The panic in London was real. Further V-2s were fired against London, Antwerp, and Remagen, the latter the only tactical use during the war of the V-2. But the rapid advance of the Allies and their overwhelming aerial supremacy meant that everything was hit and run. One major benefit of the V-2 was that it only needed a starting ramp to be set up. A 15-meter high crane could set up a V-2 in less than 90 minutes. Around 2,700 people were killed in London and 1,700 across Belgium by March 1945 when the last V-2s were fired. Like with so many things in the Third Reich, the steadily worsening situation of the war made its leadership realize their misjudgments of the past. Then suddenly, in an effort to make good for the lost time, they would embark on a great rush to turn it all around, which, of course, was bound to fail. Germany was too far gone now, but even then, it was close. To give you an idea how close it actually was, one reason why Sandys got the approval of the bombing raid against Peenemünde was that he intentionally exaggerated the reach of the V-2 to the Americans, spreading fear that New York would be within reach. The truth is, von Braun indeed had plans for such an America rocket already in 1940. He envisioned a 34-meter-long intercontinental rocket and had already figured in the Earth's rotation and curvature. Hitler simply disregarded it. Then, there was the idea of putting V-2s onto submarines, making intercontinental rockets obsolete, as these could be fired from literally anywhere on the seas. It was difficult as heck to make such a configuration work. But by the end of 1944, they had done it. It was just too late to be used. Or prototype waterfall. The idea to create flak rockets based on the V-2. Von Braun pictured a 7-meter-long remote-controlled rocket that was able to find its target and detonate on its own. He estimated it would take 2 such unmanned rockets to take down one heavy bomber. Sounds revolutionary, right? By the end of 1944, they actually built and fired around 50 of them, and the estimations were correct. But there was simply not enough steel or graphite available anymore to mass produce them. What do you think? Could Germany have been victorious if its leadership had invested in the rocket from the beginning? Or was it all a major waste of money and resources that could have been spent elsewhere? Well, such discussions are what the comments section is for. If you would like to see more specials like this one in future, then join the Time Ghost Army at timeghost.tv or patreon.com. It is the army that finances all of our productions. And if you want to see more about another piece of cutting-edge technology in this war, you can check out our special here on the atomic bomb. Ooh. Do not forget to subscribe. See you next time.